Hello there, and welcome to the 11th video that I have made you on simplifying and equivalent fractions. This is another grade 2 topic in the number stuff section, and I've got some keywords for you to help you understand the topic a little bit more. Equivalent means the same value of. Simplify means you need to make the numbers smaller, so therefore we're going to be dividing. Denominator is the bottom number of a fraction, and the numerator is the top number of the fraction. Okay, so the method that I have provided you with here, I've got two different things. To simplify a fraction, you must divide the numerator and denominator by the biggest number that fits into both those numbers. Okay, so that's what we're going to do in question number 1, and then in the rest of it we've got to find equivalent fractions. Okay, so a very similar thing, but with equivalent fractions you can multiply the numerator and denominator by the same number, and there's an infinite number of options. Again, another keyword there maybe to understand is infinite. That means there is as many as there's just an infinite number. I can't describe what infinity is. Infinity goes on forever, right? They're never ending. Okay, there we go. That's the description of infinity for you. So different types of infinity as well, but we won't go into that. So for question 1, simplifying A, B and C. Simplifying A, we've got to determine what is the biggest number we can divide both of these numbers by. Well, they are both in the 3 times table. All right, what a lot of people tend to try and do is half these numbers, right? And that won't work here. All right, that's why I haven't given you an example where you can half it straight away, which is dividing by 2. You have to divide both these numbers by 3. So if we do that, we're going to get 1 and we're going to get 9. All right, both of those numbers have been divided by 3. In B, we can also again divide both numbers by 3. Right, so if we do that, we're going to get, and I'm just going to write that there, divide by 3. I'm just showing you what I'm doing. You don't have to write this down. 15 divided by 3 is 5. And 27 divided by 3 is 9. Now this comes from, and knowing what numbers to use comes from your knowledge of your times tables. Please, people, learn your times tables. All right, it is an invaluable mathematical skill. You don't realize how often you use it until you do a lot of maths. All right, so we're going to get 5 over 9. Okay, and that's why I think people think they're not very good at maths, is because they don't know their times tables. That's a load of rubbish, right? You can be really good at maths and not know your times tables. All right, but it's going to be really useful for you, and you're going to feel like you're a lot better at maths if you do know your times tables. All right, just learn them, practice them, recite them, do it every day. It will sink in. Honestly, it will. It did for me. So that's what we got as our answer for that question there, because we divided both numbers by the same thing. Can't simplify any further. And in C, now this one I might take a couple of steps here. Might not. Maybe I won't. So what we'll do is, you can see both numbers end in a 0. And when you see both numbers end in a 0, you can divide straight away by 10. Watch the video on dividing by 10. And you know you just move the decimal place back 1 space. So you get 4 and on the top, and then you would get 15 on the bottom. Now, there is no way that we can simplify that any further because there is no number that fits into both of those numbers. So we're going to get 4 over 15 for that answer. Okay, now moving up to question 2, we've got to find 3 equivalent fractions. Now equivalent fractions are ones that have the same value as this one. So 4/7 is the one that I've given you as an example. It's got to have the same value. Now if you're going to type it into a calculator or work out what it is as a decimal number, 4 divided by 7 is a really awkward one because you get a horrible recurring decimal number, but we can find any equivalent fraction. We can just multiply this number by 2 and this number by 2. All right, and that would be our first one. Right, I think that's the easiest thing to do. Multiply both numbers by 2. We get 8 over 14. There's an equivalent fraction, so there's one of them. Okay, if we multiplied by, I'm just going to whiz that one out. If we multiplied by 3, I'll just write down what we're doing actually as we're doing it. So multiply both numbers by 3, we're going to get 12, and we're going to get 21. So there's another one that we could use. All right, now like I said, there's an infinite number of options because there's an infinite number of numbers. Numbers go on forever. So we could multiply by 10, let's say. There we go, let's have that one. Bit different, isn't it? Not really that different, but never mind. We've got 40 and we've got 70. So we could have 40 over 70. Any numbers that you've multiplied the top and the bottom by the same thing, you have found an equivalent fraction. Okay, I'm going to move myself over here again. Even bigger arc than last time. And in question 3, again, contextual, just makes it a little bit more complicated. Got to read some words, got to understand the words, got to understand what to do with the question. You've got Harry, and Harry's got 7 cards, and he wants to make an equivalent fraction to 1/3. What numbers could he use? So I've written the fraction 1/3 in words, just to be slightly more obscure, obtuse, annoying. All right, so 1/3 is this as a fraction. Okay, now let's see what numbers we could use. If we multiplied by 1, we'd get 1 again, so we haven't got a 3 on the bottom, that's not going to work. If we multiplied by 2, we could get 2 over 6, and we haven't got that. If we multiplied by 3, we would get 3 over 9, and we haven't got a 3, we've got a 9. All right, if we multiplied by 4, let's just write down multiply by 4. All right, we'd get a 4 on the top, and we would get a 12 on the bottom, and that's the first one that I've come to that I found that we can use. So we're going to use 4, and we're going to get 12. Okay, I'm going to use those 2 cards and pop them in the spaces for our answer. All right, now again, I mean that should kind of come fairly naturally to you when you know your times tables. All right, and that's 3 different types of example question on this particular topic. Feel free to click the link in the description to take you to an example. An example you can try, a practice paper, just 3 questions, very similar to this, and the answers will be there as well. Like the videos if you've watched them and found them useful, and subscribe to the channel if you haven't done so already. Thank you very much for watching, and I'll see you next time.